Welcome back, guys. So today we're going to talk about solving equations that involve exponents. Okay, and so when we do this, we're usually given a situation where we have a base raised to a power equal to a different base raised to another power. And what we want to do is we want to create or produce equality between these two bases and these two exponents. Okay, and to do that, we need to make b equal to c and x equal to d in this case. Okay, and so when we do that, that brings us to our equality of bases property, which says that in order for this equation to be true, b must be equal to c and x must be equal to d. And it says, so essentially our bases must be equal and our exponents must be equal. Okay, and this is an if and only if statement, which means that it must be true in both directions. So for example, if we have 2 raised to the power x is equal to 2 to the 9th power, then we already see that our bases are 2, so that must mean that x must be equal to 9 in order for these two statements to be equal to each other. And it must also work in the opposite direction. So if x is equal to 9, then 2 to the x equals 2 to the 9th must be true. Okay, and so let's take a look at an example of an exponential equation. Okay, so we have 2 raised to the x is equal to 8. And so the first step that we want to do in these types of equations is we want to make our bases the same. Okay, so we have 2 raised to the power of x, and we want to write 8 as a base 2 raised to some power. Okay, and so here, this one is pretty simple. We know that 8 is 2 to the 3rd. So we have 2 to the x is equal to 2 to the 3rd, and so therefore x must be equal to 3. I want to make a note that in some of these, you're going to have not fairly large, but large exponents. So if you need to review your exponents again, do that. Okay, let's look at another example. So we have something that's in the form of a b to the x, which we're used to. And we want to solve these like we solve any other equation. We want to simply undo what we are doing. So the operation between our fraction and our base is multiplication. So in order to get rid of multiplication, we do division. All right, and so what we want to do is we want to multiply both sides by the reciprocal of 5 halves, which is 2/5. So we're going to have 2 over 5 times the original equation, which is 5 over 2 times 2 to the x power equal to 80. And then we also want to multiply the right-hand side by the reciprocal. Okay, and so we know that these two cancel out. And so on the left-hand side, we're left with 2 raised to the x power times 5 into 5. 80 divided by 5 is 16, and 16 times 2 is 32. Okay, and so now we see that this step in our equation looks exactly like our previous example. And so what we want to do again is we want to make our bases the same. And so we want to write 32 as a power of base 2. Okay, and so that's 2 to the 5th, and so therefore x equals 5. Okay, so now let's look at a different situation. Here we have 7 raised to the x power is equal to 400. And so usually we want to write the right-hand side, which is 400, as a some power of base 7. But in this case, if we try to do that, so let's try to estimate what 400 would be as a base 7 raised to a power. So let's try 7 to the 3rd. 7 to the 3rd is 49 times 7, which is 343. That's a little too low. All right, let's try 7 to the 4th. 7 to the 4th is going to be 49 times 49. looking at that, we know that that's going to be extremely high and over the value that we need, because 7 to the third was really close to 400. So in this case, 400 cannot be written as a base 7 in base 7. Okay, so what we want to do is we want to use our calculator to try to figure out what our exponent should be. And how we're going to do that is we're going to make these the two sides of our equations into functions. So we're going to define f of x as the left-hand side, which is 7 raised to the x power, and the right-hand side we're going to define as g of x, which is 400. And in order to figure out what the power x is, since these are equal, we want to find out where they intersect. All right, so let's grab our graphing calculator. And remember, you want to clear your screen, so you want to second mem 712. Okay, and so let's just clear that out. Okay, and so now we want to go to our graphing tool, so y equals, and we want to plot our two equations. So we're going to have 7 raised to the x power in y1, and so y2 is just going to be our right-hand side, which is 400. Okay, and then we're going to hit graph. And so as you can see, so that would be our exponential function, 7 to the x, and then we should get a constant function or a horizontal line of 400. So since we can't see that 400, that means we need to change our viewing window. So let's go to window, and we know that we need our y to be above 400. So let's press enter, enter, enter. And so y max we need to be, let's do 425. Okay, and then let's hit graph again. Okay, and so now we can see that line, y equal to 400. All right, and so if we want to find out where these two functions intersect, remember we can go to second calc, which is second trace, and we want intersect, which is 5, so we can press 5, and it's going to ask us for our first curve, which is the exponential. You say enter. Second curve is the line y equal to 400, enter, and then they want us to take a guess, so I'm just going to press enter. And it gives us that our intersection is 3.079 400. Okay. And so for our last example, let's look at a situation where we have a town that has a certain number of residents. So a town has 78,918 residents. The population is increasing at a rate of 6% per year. The town council is offering a prize for the best prediction of how long it will take for the population to reach 100,000. Make a prediction. Okay, so in this case, we want to come up with some exponential equation that will predict how many years it will take for the number of residents to reach 100,000. Okay, and recall, since we're increasing at a rate of 6% per year, we have exponential growth. Okay, so let's grab our equation for exponential growth, which is y equal to a times 1 plus r raised to the t. Okay, where let's remind ourselves that a is our initial value, r is our constant rate at which we're increasing, and t is the unit of time. Okay, and so here our initial value is 78,918, and we're increasing at a rate of 6% per year. So remember, we want to change that rate to a decimal, and we are raising that to our unit of time. Okay, so this is our exponential growth equation for this situation. And what we want to do is we want to estimate how long it will take for the number of residents to reach 100,000. So our y in this case is 100,000, or our output. Okay, and so we have this equation, exponential equation. All right, and so we can go ahead and we can collect like terms on our right hand side. So this is going to be 0.6 raised to the t. All right, and so just looking at this equation, there's no way that we can come up with how to write 100,000 as base 1.06. So again, we're going to grab our calculator and we're going to make these into functions and find the intersection so that we can estimate how many years it's going to take to reach 100,000 residents. Okay, so again, our f of x is going to be 100,000. And remember, f of x could also be the right-hand side as well. It doesn't matter which order that you graph them in. Okay, and g of x is going to be 78,918 times 1.06 raised to the t. Okay, so let's graph that. All right, so we have that y1. Let's move this over. Okay, y1 is 100,000, so let's go up to our y1. There we go, and we have 100,000. Good. Okay, enter. And then for our second equation, we're going to have 78,918 times 1.06 raised to the power of, in this case, in our calculator, we're going to use x. Okay, and so we want to enter and we want to graph. Okay, and so we see that it's graphing because this little like rectangle is moving in the corner. All right, and so now here I don't see anything, but I know that, so I know I must change my window. So we want our x max to be, we can stay with 10, but we want to change our y min and y max. So let's change our y min to -1. And our y max, let's change it to, we know we must be above 100,000, so let's do 125,000. And so that it doesn't look like, let's change our scale to, let's say, let's increase by increments of 1,000. Okay, press enter, and then let's graph and see what we have. Okay, and so now we see our graph of both of our functions. And so again, we want to find the intersection so that we can find out how many years. And so let's press second trace to get to our calculate function menu. And then we want to press 5 for intersect. Pick your first curve, your second curve, make your guess. And then so we see that our intersection is at 4.063245. So it's going to take a little over 4 years. So in our situation, we can say that approximately 5 years, because it's not quite 4, it's a little over 4. So we can say that the time it takes to reach 100,000 residents is approximately 5 years. I guess in this case, you could say, since it's very close to 4, you could say approximately 4 years. Okay, and so that is the end of today's lesson.